Okay, so you can see that out of the 12 hydrogen of the cyclohexane, the 6 hydrogen they are lying in the axial form, and the other 6 they are lying in the equatorial position. What about there is a phenomenon that is called the ring flip. What do you mean by a ring flip? During the conformation, there's a step which occur quite usually that is called the ring flip. During the ring flip, those hydrogen which are those substituent which are axial, they become equatorial, and the equatorial become axial. You can see in this diagram the cyclohexane that the when the ring is flipping, flipping is not about this way that it is moving this way, but it is about horizontal flipping, change in the horizontal position. So if this ring flip, what would happen? The axial will become equatorial, equatorial will become axial, right? So this ring flip is quite common practice in the conformational analysis. It usually occurs. But ring flip cannot be assumed like this way. Ring flip means that it move like this way in the horizontal ways. If you do that by this way, of course, it will not be a ring flip. So this is a ring flip because this is moving up in this way or the downward, not the left to right. So what about the board conformation? So here they have drawn the board conformation. You can see here that this is the Newman projection for the board conformation. So you can see that by bringing this one into the downward side, all the hydrogen they are becoming eclipsing. They are eclipsed to each other. So that will increase the steric strain as well as the torsional strain. Of course, that will destabilize the system. That's why the board conformation is the unstable conformation, right? So board conformation, all the hydrogen they are eclipsed. So as eclipsing will rising, the potential energy and the structure will become more and more unstable. Uh, Everything that is the axial strain, torsional strain, angle strain, and the not the angle strain, the torsional strain, and this and the steric strain that will be rising up again. But here you can see that carbon number 1 and carbon number 4 uh, they are showing the flagpole interaction as well. This one. This is the most important and the worst drawback of the board conformation, that the two hydrogen at carbon number 1 and number 4 they are showing the flagpole interaction through space. This flagpole interaction destabilizes this whole system. Flagpole interaction. The chair conformation seems much more uh, stable than the board conformation in that particular sense. Okay, what about the twisted conformation? Twisted means that you overall, the center bond can be, rising up. You can see that, and I don't know whether we have the projection for that. They have not drawn it here, but if you draw the Newman projection for the cyclohexane, the Newman projection for the twisted or half chair form, you will see that the half chair is the most highly unstable structure among all the possible conformations of the cyclohexane because of many reasons. I don't know whether so half chair is the most unstable form. But what about the twisted form? Twisted form is a bit more stable than the board. The board conformation can release some of the torsional strain, at the same time and reduce the flagpole interaction. So how? By twisting. Just by twisting, the some of the strain can be relieved. That form of the conformation can be called as a uh, twist boat conformation. Twist boat conformation. But still, it is highly unstable than the chair conformation. What about the half chair conformation? In half chair, you see that all the hydrogen, most of the hydrogen, they are coming um, in the proximity near to each other, and everything is coming in the peak. So from here, you can easily understand this whole, summary. Now I have come up to this board conformation. So again, if I want to go from here to the chair conformation, what I will do? I will just keep it, I will hold on this CH2. First, I will push it up. I will come to the twist. Then I will come to the horizontal, more like near to the horizontal position. That will be the half chair. Then I will go up again twist, and again I will move to the chair. So chair, twist, half chair, twist, and then boat. So you can make a practice on this. It's a healthy practice. By doing so, you will understand that how these various conformations they are usually obtained. Uh, Look at here, how to draw the Newman projection. It's a very easy thing to do. Just look at over here. Again, you can see that you will be visualizing this carbon and this one. One of the carbon is going up, one of the carbon is going up. So you see that if you are looking at here, only this carbon and this carbon will be fully visible, but these two will be hidden. But the now this is the you can see here but that if I am looking at this carbon, I should draw both of these above like this way. You understand what I'm trying to say? That if I am interested in drawing the energy conformation, the uh, conformation for this, I have to draw it by this way, not this way. Okay. So it is this one because I am looking from here. So I'm looking from here, this carbon, this carbon, this carbon, and this carbon. So this will be visible and this carbon will be visible. This will be hidden and this carbon will also be hidden. This carbon will be hidden by this one and this carbon will be hidden by this one. I have two carbon above and it is these two one. But one of the carbon that should start from the center, right, like this way, but the other should start from the, you can cut this way, so you can start one from the center, the other from the, I mean this way, like sorry, this way, and then you can also start from the center like this way, and the other will be start like this way from the above, because that is not visible. We are only seeing this carbon fully, not this one. Only the hydrogen they are visible, right? So this is very easy thing to do. You can make a practice on, and I hope and I believe that it will not be a great deal for you to understand. The overall bottom line of this whole discussion is that the highly stable form of the cyclohexane is the chair conformation. The highly unstable form of the cyclohexane is the half chair conformation, because in the half chair conformation you can see that five of the carbon they are coming almost in one plane. I'm not saying fully, but they are almost coming in one plane. One of the carbon that is going up, and you know that whenever the whenever there's a possibility that the more carbon they are coming in one plane, there will be an increase in the steric strain, and the torsional strain up to the maximum. So this is the way you are moving from the chair to the half chair, and then in a way you see twist and then boat, twist, half chair, chair. So you can see that it is only a matter of practice. Just make a practice on this. You will come to the real picture of this whole confirmation. I don't see any hurdle in understanding all these things. It is only a matter of practice. So this is the energy perspective diagram. These are the various type of the angles, and this is the potential energy which is going up. So you see here the chair is the most stable conformation, but the half chair is the least stable conformation, and then twist. So moving from chair to the half chair, then twist, then boat, then twist again, and then half chair, and then chair. So this was all about the conformation analysis of the cyclohexane. But I will be during the on-campus class, I will be able to come up with the along with the models, and then we will try to revise all these things again by having a practice on these using the various type of the model, so that you will be able to draw the Newman projection or the Sahor's projection for these structures. Uh, if still you believe that there's any question, there's a space for any question, you are most welcome. I'll be leaving you here at this stage with the hope that you understand this. If still there's any question you can ask, you are most welcome. Thank you very much and have a great day.